All right, so here we go. This is an interesting one, law of sines. Okay, so we did law of sines already, and one thing you need to know is that every once in a while you're going to get a law of sines where you have something called an ambiguous case. And so first off, when you use the law of sines, when do you use it? It's when you're given where you know two sides and an angle. The angle's not between the two sides. It's two sides in a row and then an angle. When you know an angle, then a side, and then the next angle. Or when you know two angles in a row and then a side. But you need to be careful when it's side-side angle because this could be ambiguous. And how do you remember that that's the problem? Well, teachers all over the world, instead of, they make sure they write this in the right order, right? We always write side, side, angle. But you could also technically, you could write it as angle, side, side. But then we don't write that because that spells something bad. So we always write side, side, angles. So that's what you need to remember. If it could spell something bad, then it might be bad. And so you're still going to use law of sines, but you have to be careful of the ambiguous case. Let me explain the ambiguous case. So let's say that we have an acute A value. Okay, so it's an acute angle. And so we have angle A and we have side B. And we're looking at side A. And let's say that we know that side A is smaller than the height. Okay, so here's what's happening. This length, let's just say this goes on. Okay, the height is from the tip of B all the way straight down to A, right? And so this is the height. Now, if side A, which is this opposite one over here, if side A is shorter than the height, there is absolutely no way that side is getting all the way down to here, right? Even if I go this way, if I go this way, it doesn't matter. If it's shorter than this length right here, which is the shortest distance from the tip to the end, if it's shorter than this, there's no way. So then that means there are 0 triangles, which means there's 0 answers. Okay, so we kind of like that because if that's the case, we could just say no solution, we're done. All right, so you have to actually check, is A bigger or smaller than the side or than the height H? Now, what if we said that A equals the H? Okay, so again, here's the height, right? And what if we said A was exactly the same thing as H? So I put that in there. The only way I'm going to get to the bottom is if I go straight on top of there. And so then I have that. And so then what we have is we have one triangle, right? And in fact, we have a right triangle, so we can just use the regular cosine, sine, and tangent. But we could also use the law of sines too. Okay, now what if A is bigger than B? Okay, so what if side length A is bigger than side length B? And what that does is that just brings us way out here, and we have one triangle. Okay, there's nothing really all that special about that. I can't go in any other direction. Sometimes I look, ooh, can I go this way? But I can't, because if I went this way, it'd have to be on the inside here. It couldn't be out here, because I don't have anything out here to connect it to. It'd have to be inside, but then this is shorter than B, right? The closer you are to the height, the shorter it is. So it's longer, so I have to go way out here, and there's only one way to do that. So you have one triangle. Now here's the ambiguous part. Okay, so let me put in the height. Here's the height, right? What if A is smaller than B, but it's bigger than H, right? So this is H. So I'm going to bring A in. I can make it here. It's smaller than B because it's closer to the height. But I could also bring it out here because then it's smaller than B but bigger than the height. So technically, I have two triangles. Do you see it? Do you see the two triangles? I have, let me go in different colors. I have this little triangle right here. Okay, I have that little triangle. And then I have, let me do another color here. I have this triangle right here. So two triangles, it's kind of crazy, right? So we're going to have to deal with that. We're going to have to deal with the fact that we have that little blue triangle and that big red triangle. And we will. I'm going to show you a problem with that. I'm going to show you what to do. You're going to love it. I know you're going to love it because it's like twice the work and there's some extra thinking in there, but it'll be okay. Okay, so that's if you have an acute angle. If you have an obtuse angle, it's actually a little bit better because we only have two things that could happen. So with our obtuse angle, if side A is less than or equal to B, then it's actually impossible for us to make a triangle. And you can think about that, but there's no triangles if that happens. Okay, and if side A is bigger than side B, then we have one triangle. And we don't have to worry about two triangles with obtuse. So if you get to obtuse, you're feeling good about it. If you get acute, you have to look at the situation. So we're going to look at some examples here just to make sure that you understand. I think I have 3 examples for us to go through, one with 1 triangle, one with no triangles, and one with 2 triangles. All right. So here I have a triangle. I've got A is 42 degrees, so that means I'm going to draw an acute angle. I have side B is 12, and I have the side A is 22. Now I draw on the 22, but I should probably be careful, huh? I'm going to look at, if you look at your formula sheet, and you need to get used to doing this every single time, look at your formula sheet, and at the end it says law of sines ambiguous. And so number 1 says if angle A is an acute angle, then we have to worry about A, B, C, D. Now, side A is 22, okay, and side B is 12. So angle A is bigger than angle B. So is there one that says that A is bigger than B? And if we look at C, it says A is bigger than B. We have one triangle. Okay. Now, nothing else says A is bigger than B, so we can definitely go with C, one triangle. And what that means is I've labeled my triangle. Look at that. I've labeled my triangle here, right? And so now I can just continue on to find the rest. For example, I know that side B is 12, so I can find angle B because I can set up the law of sines. The sine of 42 degrees over side 22 equals the sine of B over 12. And then we can cross multiply and divide. And if we do that, we are going to find that B is about 21.41 degrees. And then I can find angle C because then I subtract 42 and 21.41 away from 180, and I find that C is 116.59 degrees. Okay? Then I have a third side to find, and so that's going to be side C. So we set up sine of 42 degrees over 22. Now notice I'm using that again, and that's because that was original information. I knew this and I knew this. I don't want to use this if I can help it because what if it's not right? So we use the original information as much as I can. And then we have the sine of 116.59 degrees over C, side C. So then we cross multiply and divide. And so then side C is 29.4. Now here's what happens when I'm trying to go through this fast and not do things. I forget to show you something. So let's go back. I'm going back to here, okay? So we're going to cross multiply and divide. And when we do that, I'm going to actually go through and do that. So we have sine of 42 degrees times 12, and then I'm going to divide by 22, and so we get 0.3, oh, that's not a pen. We get, let me go in red, 0.36498 equals the sine of B, and I'm going to keep that on the calculator because here's the thing, I found the sine of B, but I need to find actual B. So to do that, I'm going to do inverse. I'm going to do sine inverse of the answer I had, and I'm actually using the answer button on my calculator. Second, and then answer button, which is the yellow right above the negative sign on my graphing calculator. And when I do that, when I find sine inverse of the 0.36498, okay, when I do that, it gives me 21.406 or 41. Okay, now B is acute, so that's okay. I'm actually not going to worry about that. That's later on that we have to worry about that. So that's how I find my angle, okay, using the inverse and typing in as many things as I can there, preferably just using the answer that I got from before, using the answer button. And so that's how you find all your missing stuff there. So let's look at another example. Okay, so in this example, I have 85 degrees, and then I have side B is 25, and I have side A is 15. And you'll notice that A is smaller than B. And so if I look at my rules on my formula sheet, A is smaller than B. The only one I have is D. It says that H is smaller than A and A is smaller than B. Okay. I don't know that that's the one though, because if we look, A and B both talk about A compared to H, and I need to figure out what H is. So do you notice on the formula sheet it says H equals B times the sine of A. So we're going to figure out what that is. B is 25, sine of 85 degrees. So we plug that in the calculator. And we find out that H equals 24.9. Okay, now A is 15. So A is less than H, right? Which means we have A. A is less than H means no triangles. So this actually has no solutions because there's no triangles I can do this with, right? There's absolutely no triangles I can do this with. So we're done. That's it. We like that one. The next one, however, is so simple. Okay, on the next one, we have that the angle is 20.5 degrees. I have side B is 31, and I have A is 12. And so once again, A is less than B here, but that only happens, well, I don't know. It could be A, it could be B, and it could be D. So I have to figure out which one is it. Okay, so once again, I do H equals B, which is 31, times the sine of A, which is 20.5 degrees. 31 times the sine of 20.5, and we get that H equals 10.856. Well, that means A is bigger than H. So A is bigger than H, but A is smaller than B. Ooh, that's backwards, but it's still D, right? It matches up with D. So that means we have two triangles. Okay, so what's happening, let's look at the picture. If I draw in the height here, the height is only 10.8, right? So I either have this triangle, the 12, that goes out here, or I could have the 12 that goes in here. So I have one of two triangles. I have, let's make it a green triangle. I have a green triangle right here, so I'm going to draw that right here. Okay, where the angle is 20.5 degrees. I have a 31 and I have a 12. Or I have the blue triangle, which I'm going to draw over here, which is 20.5 degrees, 31, and 12. I have two triangles. And so now it's time for us to find the rest of the stuff for these triangles. So I'm not really sure where it's going to give us the answer first. You'll understand in a second what's going on. So what I need to do is I need to find that other angle, right? I need to find the angle that's across from the 31. So I set up sine of 20.5 over 12 equals sine of B over 31. I cross multiply and divide. So the sine of 20.5 times 31 equals, divided by 12, that gives me the sine of B equals 0.9. I do the inverse, right? Inverse of sine, put in my answer, and it tells me then that B equals 64.7, 0.8 degrees. Let's go with 64.8 degrees. Okay? Now, you got to think about this. I'm finding this angle here, right? Which one is 64.8? This one's going to be obtuse. This is really big, right? This is an obtuse angle. Is this 64.8? No, this is more than 90. So that means this one's 64.8. So 64.8 degrees. And then I can take 180 minus 20.5 minus 64.8. And that means that this one is 94.7. And then I can use law of sine, sine of 94.7 over c equals sine of 2, do all that. And you find it, cross multiply, and you find the c value, right? Okay. So then we find the c value, and I'm trying to see if I have the answer. I don't have it written down, but you get what I'm talking about. Okay, so that one's done. What about the green one? What is this angle? So we got to talk about this. So you know how sine is restricted when we do the inverse of sine is restricted in the first and fourth quadrant. So when we did sine inverse of 0.9, it gave us 64, right? It gave us 64.8. Okay, but let's get out of that. Let's get out of that restriction, and let's say, okay, sine is positive, right? It's 0.9, positive 0.9. So it's positive here. Where else is sine positive? It's also positive in the second quadrant. And think about that for a second. If I do that in the second quadrant, this angle here is obtuse, isn't it? It's bigger than 90 degrees. So I have to figure out what's this blue angle. Well, don't forget, this angle is the reference angle right here. That angle right there is 64.8. And so to find the blue angle, I'm taking a full 180 and take away the 64.8. So 180 minus 64.8 gives me 115, right? 115.2 degrees. That, my friends, is that angle right there, 115.2 degrees. Okay, that's where my obtuse angle comes from. You may have to watch that a couple times to really understand it, and maybe even let it sit in and come back to it the next day. It takes a while to let this sit in. It takes a bit of practice, but that's how you find that angle. And then I can take 180 minus the 20.5 minus the 115.2, and I get my third angle, which is going to then be 44.3 degrees. And then I can set up the law of sines to figure out my C value. And so I shouldn't need to go over that with you. You should have plenty of practice for that. But that's how the ambiguous case works. Good luck. Watch it several times if you need to. Hopefully you can grasp it or have someone help you grasp it, but that's how it works. Good luck.